All right, so this is going to be Unit 4, Lesson 6, so features of graphs. So 6.1 is walking home. This is supposed to be like your warm-up. So we have Diego is walking home from school at a constant rate. This graph represents function D, which gives his distance from home in kilometers in minutes since leaving the school. So we're going to use this graph to find or estimate. We have our function, so D of 0. Our 0 here, so the D, we have the distance is a function of time, and so our time is going to be in the parentheses. It's our independent variable. Our independent variable is always going to be our input. Some of you guys have been struggling with that. So I'm going to look at 0 minutes and go up and see that my point is going to be at approximately 2.25 kilometers. I'm going to do the same thing on this next one. We have D of 12. So our distance from home at 12 minutes after leaving school. So we're going to look at our 12 and go up and see that it is just below the 1. So I'm going to say it's about 0. It's a little over the halfway point, right? The halfway point would be about there. That'd be about 0.75. So I'm going to say it is about, let's say 0.85 or 0.9 kilometers. Somewhere between there. Now we're going to look the other way. So we have our distance. We have the solution to our distance in minutes. So our distance is a function of minutes equals 1. So now I'm going to be looking from this side of my graph. I'm going to look at the 1 and see that I am about 11 minutes or 10 and a half minutes. So M is approximately, let's say 10 and a half minutes. We can just say, we'll say minutes. We'll just write it out. Okay. The solution to the distance as a function of minutes equals 0. So our distance from home at 0 is about 20 minutes. So, and I think that's probably exactly 20 minutes. So M equals 20 minutes. All right, we're going to go on to 6.2. It's on my next page. It's probably starting on the same page that you guys were on. We have a toy rocket and a drone. A toy rocket and a drone were launched at the same time. Here are the graphs that represent the height of the two objects as a function of time since they were launched. Height is measured in meters above the ground, and time is measured in seconds since the launch. Analyze the graphs and describe as precisely as you can what was happening with each object. Your description should be complete and precise enough that someone who is not looking at the graph could visualize how the objects were behaving. Okay, so first we are going to analyze the rocket. So we're going to look solely at this one right here. Okay, so the toy rocket was launched. From a height of 25 meters above the ground. And we can see that right here at 0 seconds whenever it left the ground. it was launched at 25 meters, right? So when it was launched, it was at 25 meters. Okay, it went down. Oh, no, sorry. It went up quickly, not down. It went up. But it slowed down and then stopped, getting higher when it reached 45 meters. Which was 2 seconds after launch. Oops. L-A-U-C-H. There we go. Okay, so we can see that our maximum was right about here, which is about 2 seconds after the rocket was launched. So at that point, it started to come back down. It hit the ground. Oops, I'm going to make that spacing a little bit better. It hit the ground. Five seconds after it was launched. Okay. All right, so we can see up here that about 5 seconds, that's where it hit the ground. Okay, so that's when it got to the 0. Now let's look at the drone. So the drone took off from the ground. So here's our difference. The rocket took off at 25 feet. The drone took off right here. So at 0 seconds, we can see the drone right here at this point. So the drone was launched. Or sorry, the drone took off. That's how it has it worded. Okay, so the drone took off. From the ground. It went up at a constant speed. For 2 seconds. Up to a height of 20 meters. I cannot spell today. So if I look up at my graph, I can see that constant speed. It's a constant speed because it's going to have a slope. So if it is like a straight line. It's going to have a constant speed. Up here on our rocket, it did not have a constant speed because it is a curve, not a straight line. We go up on our drone up to 20 feet here. And then it stays pretty steady. It's hovering because drones, obviously, if you've seen one, it just can stay there, right? So then it hovered hovered at that height. For 3 seconds. Afterward, it started descending at a constant speed for 2 seconds. It landed back on the ground. Seven seconds after launch. Okay, so if I look back up here, so here's our hovering, okay, and then here's our descent. We can see that that is at a constant speed right there, okay, and that was, so we hovered for 3 seconds, and then we descended for 2 seconds, and landed on the ground at 7 seconds. I also want you guys to pay attention to this point right here at about 4.5 seconds. Both the rocket and the drone were the same height. Okay? So about I'd say 4.5 seconds. I'm going to add this over here to the side. So after 4.5 seconds, the drone and the toy rocket were at the same, extra little bump in there, height, which was 20 meters. All right, we're going to go to the next question, which it's possible that this is on the next page for you guys. And I know you may not have had this much space, so just kind of paraphrase it if you need to. You need to know the gist of all of this. I can't remember how much space you guys have on your paper. But we're going to go to the second question, which is on my next page. So, which parts or features of the graph show important information about each object's movement? So, if we look at your guys' graph, which you guys don't have, I don't think, this extra graph on here that I have from the activity synthesis. Okay, so we're going to talk about these different things that are super important. We're just going to graph them on here, on this graph that I have. So, features that were important on that graph on the last page. So, one could be the points. where the graphs begin. So that's going to be when t equals 0. So from our rocket, that was at 0.25. For our drone, that was at 0.0 because we started on the ground, remember? So those are important points. Another set of points that is real important is going to be the points where the graphs cross the horizontal axis. So the points where the graphs cross the horizontal axis. That's going to mean that our height in meters from the ground is 0. So I'm going to put in parentheses height equals 0 meters. Okay, so for our rocket, that was 5 seconds. So that's going to be 50. Actually, I'm going to go ahead and just label these. I'm going to label this as 0, 25, and 50. And this one over here is 0, 0, and 70. Okay. Another important point is going to be the point where the graphs change direction. Okay, so for our rocket, that is going to be our maximum point whenever it changes direction. That was it around 2 seconds? We got up to about 45 feet, I believe is what we said. So somewhere in here, that is going to be 2:45. So for our rocket, that is going to be our maximum. So from at 2:45. For our drone, we have 2 different changes. So we have the change at 2 seconds whenever it gets up to 20. So when we went from increasing height to hovering at 220. And then it has another change where we went from hovering to decreasing height. Which was 520. See here, I think that was a little bit too high. There we go. Let's get there. So at 520. Okay. Let's see here. Another thing that's important to note is the shape of each graph. So our rocket's shape was curved, right? Our rocket had a curved graph. And our drone, it was composed of straight lines. So we're just going to call that a straight graph. Or straight. Let's just say straight lines compose the graph. Okay. Let's see here. The intervals when the graphs behave certain ways. So that could be kind of like over here where we were talking about the maximum and then the increasing height to hovering and then the hovering to decreasing height. And then I think that's good for that one. Let's go on to the next section, which is 6.3. All right, so we have a bungee jump. The height of the jumper is a function of time since the jump begins. Function h defines the height in meters of a jumper above a river t seconds since leaving the platform. Here's a graph of function h followed by 5 expressions or equations and 5 graphical features. So we have h of 0, and that's going to represent the first dip in the... Oh, no, wait. Let's see here. We need to match those so these don't go together. So we have h of 0. That is up here. So h of 0 is going to be... I think it's going to be our maximum here. Okay? That is our maximum because... Oh, no. That's not going to be our maximum. That's going to be our horizontal intercept. Because... You know what? My brain is not working today. That's our vertical intercept, right? Okay. H of t equals 0. So that one is going to be our horizontal intercept. H of t equals 0. Okay. So h of 0 that's giving me, here, this is why my brain was not wanting to do this. So that was t equals 0 in this first one. So at 0 seconds, it's going across the y-axis, which is our vertical axis. And then h of t equals 0. That is going to give me, my y value is going to be 0 there. So at 0 on the y-axis, we have t seconds. We can't see that on this graph, obviously, right? Okay, so if I look at h of 4, so my t equals 4. That is, let's see here. We're going to call that our first dip in the graph, because that's when it's going down, right? It could potentially be this point right here. And honestly, it probably is that point that they're talking about. Then we have h of t equals 80. H of t equals 80. That is going to be our maximum. And that leaves h of 45 to be our first peak in the graph. So down here, you guys actually have a table that we're going to fill in on this. For me, it's on the next page. It may be on the same page for you guys. So we have the greatest height that the jumper is from the river. So that's going to be our maximum. Which is h of t equals 80. The height from which the jumper was jumping, that is going to be h of 0, which was the vertical intercept. Actually, I'm going to make that a little bit smaller so that I have a little bit more space to write that in that box. Vertical intercept. The time at which the jumper reached the highest point after the first bounce. So that's going to be h of t equals 45. That was the first peak. I'm going to write that smaller and up here. First peak in the graph. Okay. Okay, now we have the lowest point that the jumper reached in the entire jump. So that is going to be h of 4. That's going to be our first dip. In the graph. All right, so that's going to leave our h of t equals 0, and that was our horizontal intercept. So here's what we're going to fill in over here, because you guys don't have this yet. This is going to be the time at which the jumper hits the surface of the river. All right, we're just supposed to estimate h of 0 and h of 4. So if I go back over here, if I look at h of 0, we're going to say it's approximately 80. So h of 0 is about 80. And what are we in on this one? We are in meters. Okay, now we're going to look at h of 4. And that is, so h of 4 is going to be probably that one, right? 4 seconds is about 10. About 10 meters. Okay, now we are going to estimate the solutions to h of t, so the height as a function of time, equals 45. So about what time is our height? 40, oops, that's 40. I need to go up to 45. So it should be about halfway, and I would assume that they're talking about this point right here, which is at about 9 seconds. Okay, so h of t equals 45 for t equals 9 seconds. I believe that's what we're in on this one, 9 seconds, yep. All right, and then h of t equals 0 for, let's see here, we're going to go back over, oh, look, I missed something. Right there, we're at 45 as well. So we have 45, oops, I went back 2 instead of forward. Or t equals, not or, let's say and, because it does do that. T equals 2 seconds. So I'm sorry, I should have just looked off of this and went all the way across to find my points. Okay? Then we're going to look for h of t equals 0. And if I look over here, my line, I'm going to change this color. Let's do a lime green. My graph does not hit h of t equals 0. So we do not ever get to the height during that time frame. So h of t equals 0. Let's say cannot be found on the graph between 0 and 35 seconds. All right, make sure that you guys do your practice problems on Canvas, and I will see you guys hopefully on Friday if you're A-Day students, and I'll see you on Thursday for my B-Day students.